Hello and welcome to lesson 4.4 over congruent triangles again. Today we're going to look at how to show that triangles are congruent by using some of what we called shortcuts. We previously looked at how to prove triangles are congruent using the definition, which we had to show three pairs of congruent corresponding angles and three pairs of congruent corresponding sides. But now what we're going to show you is there's actually a way to do it showing less steps, and that's through what we call side-side-side congruence and side-angle-side congruence. We're going to talk about those in this lesson. Like I said, previously we used the definition of congruence to prove triangles are congruent, but now we get to use shortcuts. We'll use side-side-side postulate and side-angle-side postulates to test for triangle congruence and to prove triangles are congruent. So let's learn what those are. First, we have side-side-side congruence. Now from here on, make sure you're using the additional notes pages I gave you for lesson 4 and lesson 5. The other notes in your stapled packet won't necessarily match up with what you have here in the video. So in example 1 and 2, I'm sorry, 1A and B are not going to quite look like what you have in your stapled packet. You actually won't even have these. So when we get to that, make sure you are on the additional pages that I gave you in class. And if you were absent and watching this video on your own, you'll need to get these pages from me. You can still take notes in the packet using what you do have. You won't have everything line up correctly. So let's talk about side-side-side congruence postulate. It states if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. We don't even have to show that the angles are congruent. And this is based on something that we call triangle rigidity. The word rigid meaning stiff, unmoving. If I have three sides of a triangle, and those three same lengths are used, there's only one way we can arrange those in a triangle. The angles would have to be the same no matter what else. Even if you flip it around, you're still going to have the same angle measures, just in a different position. So we can use side-side-side to prove triangles are congruent. So we're going to try and attempt to do that in example 1. Here we're given triangles ABC and DBC. With given information marked on the diagram, we want to show that these triangles are congruent using that side-side-side congruence. That means I need to show three pairs of congruent corresponding sides. So we've got AB and DB that are congruent because it's marked that way. That's the given information. And AC and DC are again given as congruent. So the third pair of sides to be congruent would have to be this third side in each triangle. Well, you'll notice they both share segment BC as that third side, and BC is again congruent to itself by the reflexive property. So here's what I want us to write. It is given that AB is congruent to DB, and AC is congruent to DC. Also, BC is congruent to itself, or to BC, by the reflexive property of congruence. Therefore, and remember we talked about this symbol means therefore, triangle ABC is congruent to triangle DBC by side-side-side. Alright, let's see if you guys can try and piece together an explanation for part B. Again, using some of that same kind of information, you'll notice AB is given as congruent to DC, AD is congruent to CB. So see if you can write an explanation kind of like this as to why the triangles have to be congruent by side-side-side. Alright, if you need more time, pause the video, but otherwise this is what we should get. We're given that AD is congruent to CB and CD is congruent to AB, and we know AC is congruent to AC by the reflexive property, so triangle ABC is congruent to triangle CDA by side-side-side. Alright, we're going to take a look here at writing a flowchart proof, or a flow proof, and I've given you this on the video. You don't exactly have this information in the note page, but this is what we're going to use as our template. Don't try and copy it down first, so don't pause the video and try and copy this down real quick. Just kind of copy it down as we go. Alright, so here's what we are given. We're given that we have triangle QRS, that big triangle that's combining these two, is actually isosceles with QR congruent to SR. Go ahead and mark those in the diagram after you read the given, if they're not already. But then we also know that RT bisects angle or segment QS. That's going to tell me that T is the midpoint, or more specifically, that QT is congruent to ST. And so we want to be able to prove that these two triangles, the one on the left, one on the right, are congruent, and we should be able to use side, side, side. In order to use side, 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 all three sides must be concluded as being congruent, and mark the diagram as you go. So let's start through here. The first thing we're going to do is start over here on the left. We're going to make this statement with a box around it. We know that QR is congruent to SR because that's given, even though they word it a little more shortly and succinctly than they do in the given step here. That's really what we're focusing on. And that is a pair of congruent sides. And so, kind of like we made our checklist earlier, we've got one pair of congruent sides. I need another pair of congruent sides, and so that's where I'm going to go to the next given statement. That segment RT bisects QS at T. That's given. But that is going to tell me something else. All right, that statement doesn't conclude that segments are congruent. It leads me to this conclusion here, that segments QT and TS are congruent. There's another pair of congruent segments, and that is by definition of bisector, or definition of segment bisector. And that's going to lead me to the fact that the triangles are congruent, but I need one more pair of congruent sides. Well, if we look, both triangles share side TR. So TR has to be congruent to itself by the reflexive property. That's, again, something we're going to use a lot in this chapter. So we've shown three pairs of congruent sides. So we can say the triangle QRT is congruent to triangle SRT by side, side, side. Alright, that leads us into getting ready to talk about the side angle side congruence postulate. But before we do that, there's a term we need to use, and that is called the included angle. An included angle is an angle formed by two adjacent sides of a polygon. Okay, think of it as an angle that is kind of sandwiched between two adjacent sides. That word adjacent meaning next to. We could also use the word consecutive to describe those sides. Okay, so we have what's called the side angle side congruence postulate. It says if any two sides and the included angle of a triangle are congruent to the other two corresponding sides and their included angle of a second triangle, then the triangles are congruent. So let's say we had BA and DE marked as congruent, and BC and FE marked as congruent. The included angles B and E would also be marked as congruent. Then the triangles are congruent by side angle side, or SAS. So let's see if we can kind of word our description of why these triangles are congruent in example 2a. This diagram shows part of some support structure for a tower. You'll see these kind of intersecting triangular patterns a lot in those kinds of architecture. And what we're trying to show here is that by side angle side, these triangles are congruent. So let's look at what we have. We have XZ congruent to VZ. So if these are congruent, the same length. And we have WZ congruent to YZ, if these are the same length as each other. There's our two pairs of sides. The included angle between these two marked sides has to be this angle. The included angle between these two marked sides has to be this one, and those would have to be congruent angles. That'd be by the vertical angles theorem. So here's what we can say. Given that segment XZ is congruent to VZ and segment YZ is congruent to segment WZ, angle XZY is congruent to angle VZW, by the vertical angles theorem, I just about wrote something else, but by the vertical angles theorem, so triangle XYZ is congruent to triangle VWZ by side angle side. Alright, let's take a look at part B. We again have triangles laid out like this, and we have triangle ABC and triangle DBC. We are given AB is congruent to DB. You are given angle ABC is congruent to angle DBC. We want to be able to use side angle side. Well, I've shown sides. I've shown the included angles, so the sides that must be congruent have to be on the other side of those two angles. Well, that's the shared side BC. So why don't you try and write that explanation of why these triangles are congruent using side angle side. Again, use this process as your guide. Alright, if you need more time, go ahead and pause the video. Otherwise, this is what we should have. It is given that AB and DB are congruent and angles here at B are congruent, and by the reflexive property BC is congruent to itself, so triangle ABC and triangle DBC are congruent by side angle side. Alright, we're going to quickly try and look at these. We're not going to do as much writing on either of these. We're just trying to figure out if you would use side side side, side angle side, or neither to prove that the triangles are congruent. And there's a reason these all look the same. We are given the marked information, but we're also going to be given a different statement for each of these examples. And we want to figure out which of these two we would use, or if neither one apply, then we write neither. So let's take a look. In example 1, we're given these are congruent segments, but we're also given that A is the midpoint of JN. I'm going to mark that to mean that these two segments are congruent if A is the midpoint. Well, I've got two sides congruent here, two sides congruent here. Can I tell that the third sides are congruent? Yes, we can. The third sides here are the shared side AK. Since AK is congruent to itself by the reflexive property, we would use side side side. Let's try example 2. You're again given JK and NK are congruent, but then they also say that KA bisects angle JKN. So this is an angle bisector of the bigger angle at K. Well, that shows me these sides are congruent. These angles are congruent, so it's probably going to be side angle side, especially when we look at the third, or the shared side here, making these two angles the included angles between congruent sides. So yes, we can say these are congruent by side angle side. Alright, let's look at the last example here. We are given the same information here, but then they tell you angle J is congruent to angle N. So I've got congruent angles here, I've got congruent sides here, and then I also have the same congruent side AK to itself, but angle J is not the included angle between side AK and JK. Just like N is not the included angle between NK and AK. So since A is not the included angle, if I tried to arrange these, they would be angle side side. Well, we can't write that, and if you try and write it out, you'll recognize why. And that not just because it's an inappropriate word, it's just because this theorem doesn't actually exist. There is no angle side-side congruence theorem. So we want to write neither. Even though these might be congruent triangles, I can't use either of these two to say so. Alright, real quick we'll wrap up this proof, and then we will continue with our final proof in class. We are given that the wings appear to be congruent triangles. We want to prove that given FG and HG are congruent and that JG bisects angle FGH. So I want you to try and write a paragraph proof to prove these triangles are congruent using either side 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 or side angle side, and then when you're ready you can check your answer. Pause the video so you have enough time to do this, otherwise this is what you should get. Since we're given these congruent sides and that this is an angle bisector, we have these angles are congruent, and GJ is congruent to itself by the reflexive property. Triangles are congruent by side angle side.